This is problem number 55 from section 2.7 where we have been graphing rational functions. So in class today we left off with this function. We found the x-intercept, the y-intercept, and now let's go through the process to find the asymptotes. So recall, for any vertical asymptotes, we find where the denominator, once factored, will equal 0. Recall, we cannot factor the numerator. We can also not factor the denominator. We have a sum of 2x squared plus 1. This is not factorable. So there are no factors in the numerator that cause factors in the denominator to cancel. So we know we don't have any wholes. If I set this denominator equal to 0, and solve for x squared, I eventually get to the point where x squared equals negative 1/2. And if we take the square root of both sides, we come out with x equals I on the square root of 1/2. This tells me that any vertical asymptotes would be imaginary. Therefore, we do not have any vertical asymptotes, so there are none in this case. For our horizontal asymptotes, recall that we compare the degree of the numerator to the degree of the denominator. In this case, we have a function that is top-heavy, and top-heavy functions have no horizontal asymptote. Well, what about slant asymptotes? The degree of the numerator is 1 greater than the degree of the denominator. So yes, we do have a slant asymptote. To find that slant asymptote, we will divide the numerator by the denominator. And recall, when we divide a degree 3 by a degree 2, that will reduce this to a degree 1 polynomial. Recall that degree 1 polynomials are linear, and a slant asymptote is linear. So let's do that division now. So we will divide 2x squared plus 0x plus 1 into our numerator, x to the third, plus 2x squared plus 0x plus 4. To begin, we divide the first term inside by the first term outside. So I'll come up here or down here and do a little bit of scratch work. X to the third divided by 2x squared will reduce to x over 2, or you can also think of that as 1/2 x. Recall, when you're performing long division, it's very helpful to keep the like terms lined up vertically. So this is x to the first over 2, or 1/2 x. So I will keep that above the 0x. And then when we multiply, we have to distribute to all three terms. 1/2 times 2 is 1. X times x squared is x cubed. Plus 0x squared. Plus 1/2 x times 1 is 1/2 x. Remember that our next step is to subtract. So that would, in this case, change the sign of each term. And these two terms will cancel. We have 2x squared minus 1/2 x. And then we bring down the plus 4. Continuing to divide, we'll now divide the first term by the first one on the outside. So 2x squared divided by 2x squared is 1, so positive 1. Now remember, your goal here was not to divide, but to find the slant asymptote. Recall that a slant asymptote is a linear function, y equals mx plus b. So once you have y equals mx plus b, you may stop the long division. We now have the equation of our slant asymptote. So let's take our information and sketch it now. So we have an x-intercept between -2 and -3. We have a y-intercept of 4. We did not have a horizontal asymptote. We did have a slant asymptote of y equals 1/2 x plus 1. So to sketch that slant asymptote, we'll begin with the y-intercept of 1, and then our slope is rise over run, up 1 over 2, up 1 over 2, up 1 over 2, and so on and so forth. Down 1, left 2, down 1, left 2. All right, let me draw that slant asymptote. All right, so we have an x-intercept, a y-intercept, and then that's basically it. So this might seem difficult to draw. So what could you do to help you get a few more points? And of course, you could use a table of values. So I'm going to use a table of values. I'm going to choose -10 to help me determine where I am to the left of this x-intercept. When I plug in -10 to our function, I come out with a y value of -3.96. Now, let me go ahead and say right now, you know on your test you will not be allowed to use your calculator. I will make sure that I give you numbers that are easy to calculate without your calculator. So, nonetheless, -10, -3.96 is approximately located here. So I know at this point I have to go through my x-intercept. I have to go up to the y-intercept. How did I know to cross my x-intercept? The degree was odd, that therefore we cross. And then what about to the right side of this? So I'll plug in +10 at this point. So that's +10 and a y-coordinate of 5.99. It's approximately here. So I know that I'll come back towards my asymptote and then, oops, sorry. Okay, try to feel like that's smooth and straight.